Clean Sky is a major endeavor in aeronautical industry in Europe. Its main purpose was to deliver an improved environmental impact of all aviation sector. As part of the original program, different platforms, System for Green Operation was one of the most interesting one to be launched, as interface with most of the other platforms and targeting several new equipment, new technologies, ground test bed and flying test beds.
Clean Sky expressed the need to flight test some new technologies, and Airbus' response was to put in place a dedicated organization in order to make these flight tests. The first deliverable of this organization is the Flightlab #1 with electrical innovation on board.
We launched Flightlab because experimental data are much powerful than synthetic data. They represent the real life of the aircraft.
The main challenge is to balance the representativeness needed for future technologies made for future aircraft and the constraints you have with the current platform. We design a flexible and robust architecture. In this architecture, we have a primary in-flight detection system, an electrical power center, enhanced flight test instrumentation. We have also an improved air intake, and finally, an electrical environmental control system.
For this development aircraft, we, Airbus Electrical System Engineering, have developed an E-ECS, Electrical Power Center. The main function of this E-ECS is to provide high voltage DC to the air conditioning system, provided by Liebherr, from the APU generator. This E-ECS development is really key for us because it's the first time we actually make such a technology fly in real environments.
We want to learn about this new HVDC voltage, about new components and key drivers for this technology.
The Liebherr technology is called the electrical environmental control systems. The main idea behind is instead of taking air from the engine of the aircraft, is to take air from outside the aircraft and to do with the same equipment both the pressurization and the air conditioning systems.
A flight test demonstration has enabled to validate 3 objectives. So the integration of the system in the aircraft, the validation of the performance in all operating conditions, and the validation of the control laws with focus on transient modes.
The inlet is a fresh air intake type. There are 2 other features of this intake. One is an ice protection system, and the other one is noise treatment for the electrical air conditioning system.
It's the first time to use a mini infrared camera for the rugged environment for the flight test installation. The benefit for the team is to analyze another type of data.
The PFIDS will detect the ice accretion on the surface by using a laser to have a very robust capability to detect and to discriminate the icing condition.
In parallel of new technologies, we also developed and test new methodologies and tools. For example, we used a system engineering approach with Gaia tool. We also experiment virtual reality and enhanced reality during this project.
My personal involvement in the Flightlab was, first of all, to initiate the activity. About a year after, to be the chairman of the CDR. This means the design freeze. And more than a year after, to be a pilot of the Flightlab.
I would like to thank all the teams, Airbus and partners, for their fantastic work.
It's really a success and achievement of the program and is paving the way for any further exploitation in the future.
Yes, we made it. We learned a lot and it's a huge success.